and welcome to Prof. Dan Tutorials. Please kindly subscribe to our YouTube channel, Prof. Dan Tutorials, so as to get updates at any time. Okay, our focus today is to look at area of composite figures, part 1. Okay, what are composite figures? We'll be looking at what are composite figures, and we're going to recall some areas of basic shapes. Then we'll solve some examples. Okay, now to start with, we'll look at a square. A square. A square has four parts of, let's say, four sides. Okay, and all the sides are equal. All the sides of a square are equal. Okay, so if we say one side is referred to as length, that is, all the remaining four sides are also length. Okay, and to find the area, you recall that the area of a square is simply the square of its length. Okay, that is length times length. Okay, so if you have, for example, you have a given square, and let's say this side is 3 meter. Okay, this side is 3 meter. Don't mind the dimensions, they are not the same. Okay, so the area in this case is the product of the length, which is 3 times 3, and that gives us 9 meter squared. Okay, also let's recall for a rectangle, we remember that for a rectangle, it only has two pair sides that are equal. This side is equal to this side, okay, and this side is also equal to this side. So if this is taken as the length, okay, that means this is also the length. And if this side is taken as the width, then this is also the width. Okay, width. So we say the area of a rectangle is the product of its length and width. As a quick example, so if you have a rectangle and this is 6 meter, while this is 3 meter, what would be its area? Simply put, as area equals the length, which is 6, times its width, which is 3. And this gives 18 meter squared. So this is just a quick review of how to find the area of basic shapes. Okay, quickly we'll look at a circle. In one of our videos, we've established that the area of a circle is pi r squared, where r is the radius of the circle, that is, from the center to a point on its circumference is the radius of the circle. Okay, and in some cases, the value of pi is given as a constant as 3.14 in most cases. Okay, number 4, we also review a triangle. This is the shape of a triangle. A triangle in this form has a height h, okay, and the base b. The base b of the triangle and the height. The area of a triangle is simply half, that is 1/2, multiplied by its base and its height. Okay, and next let's look at parallelogram. In the case of a parallelogram, a shape that comes in this form, we also have the base. Okay, this side is the same thing, is equal to this side. Okay, and the height of the parallelogram. So this is the height, and its area is given as the product of the base and height. All these are what we are familiar with. Our main subject today is how to find the area of composite figures. What are composite figures? A composite figure is one that is made up of two or more figures, that is, two or more shapes. For example, we can have a figure to comprise of a rectangle and let's say a triangle, and it can even have a semicircle. So this is one figure comprising of three different shapes: triangle, a rectangle, and a semicircle. So to find the area of such figure, you need to decompose, that is, split it up into a recognizable figure. To decompose this, I know that, oh, I have a triangle, okay, which I know. I have a rectangle, and I have a semicircle. Okay, once you find the area of each of the figure, you can add as the case may be, or you may subtract depending on how the composite figure is. Quickly, we look at basic examples in this part 1 video of area of composite figures. Okay, question 1 says, find the area of the figure. This is a figure. So the first thing you should do is, can you split the figure into recognizable ones? Yes. So in this case, I have a rectangle and half of a circle, which is a semicircle in this case. Don't mind the figure, okay? So like half of a circle, okay, and that's a semicircle. So here is 8 centimeter, and here is given as 3 centimeter. Okay, if this side is shared by the rectangle and the semicircle, so it means that here is also what, 8 centimeter. So I will call this figure 1 and this is figure 2. So to find the area of the figure, first I need to find the area of figure 1. Figure 1 is a rectangle. Area of a rectangle is length times the what? The width. So I can have 8 times 3, and that gives me 24. The unit, in this case centimeter times centimeter, gives centimeter squared. So I also have to find the area of the second figure, in this case, which is a semicircle. Okay, a semicircle. So area of a circle, you recall that the area of a circle is pi radius squared, and the area of a semicircle, since it is half of a circle, is half times that of a circle, pi r squared. So the area of 2 in this case is half pi r squared. So which gives 1 over 2 times pi times the radius of this semicircle. The value given here is the diameter of the circle. Recall that radius of a circle is diameter over 2. Okay, so that means that our radius is going to be 8 divided by 2, which is 4. So I put the value here. So the radius is 4 all squared. Okay, if my calculator is allowed, I have 1 over 2 multiplied by pi multiplied by 4 squared, and that gives 8 pi, which is 25.13. So I have this as 25.13 centimeter squared. So finally, since the question is the area of the figure, so this figure composed of part 1 and part 2, and this can therefore be written as our area is equals to the area of figure 1 plus that of 2, which finally gives 24 for A1 and our A2, which is 25.13, and this can finally give 49.13 centimeter squared. Finish. Okay, I hope you understand. Now try to solve more examples. All you need to do is split the composite figures into different parts that you can easily recognize. Okay, now we look at two more examples. For question 2, let's see how to go about this. Find the area of the figure. So as first examine the figure. Okay, it's composite. The next thing is what are the shapes or the figures you can easily see. So this can be split into two. I have this as part 1, which looks like this part, which we can see that it is a square. Okay, and we have the part 2, which we can see as a triangle. Okay, so I have my A1, which is area of a square. In this square given, we have one side of the square is 6 centimeter, another side is 6 centimeter. So this shows that it is a square. So the formula, remember, is length squared. So the length is 6 squared, which means 6 times 6, and that is 36 centimeter squared. We also need to find the area of the second part, which is a triangle. Now be very careful. This is the triangular part, okay? The total length from here to here is given as 10. But we are interested in knowing this part, this base of the triangle. We need to know this part of the triangle. Okay, from here to here is known as 6. So if you know from here to here as 6 centimeter, and from this point to this point is 10. How do you know this point? It's simply 10 minus 6, which is 4. So it means this part is 4. From this point to this point, 6. From this point to this point is 4. 6 plus 4 gives you 10 from this point to this point. Okay? So in the triangle, the base is 4. So you have something like this for the triangle. So this part is 4 that is needed. And we need the height of the triangle. This is the height of the triangle, which is also one of the side lengths of the square, given as 6. So this is 6. Applying the formula for finding this type of triangle's area, which is half times the base. The base here is 4 times the height of the triangle, 6. And this can finally give 2 goes here 1. How many 2 do you see in 4? 2. You are left with 2 times 6, which is 12 centimeter squared. Okay, so as the figure appears, it shows that we are going to sum up, that is, add the area of this figure 1 and that of figure 2. So your final area is going to be that of figure 1, 36, plus that of figure 2, which is 12. And this finally gives 48 centimeter squared. Okay, now we look at the last example. Okay, example 3. Find the area of the figure. Okay, all you need to do as usual is to observe what you have. So by mere observation, I can see this part. I can see this part of the figure. Okay, okay, and I can see this other part of the figures that looks like a normal shape that I know of. Okay, that looks like a triangle. Okay, so in this case, that means that the figure is made up of two parts, which is the rectangular part and the triangular parts. So first, so we can call this part 1 and this is part 2. Okay, this is like a house with a cap on it. Okay, now for the part 1, which is a triangle that we can see, we have the triangle like this, and now we need to do a bit of mathematics here. Okay, now we also have this part, the rectangle. Okay, for the rectangular part, part 2, part 1, we know this part as 20 meter, and we know this part as 4 meter. Well, the dimensions are not really up to scale. Okay, so now for that of the rectangle is quite easy to do. So let's find the area of the rectangular part, which is A2, as what? The length, which is 20, this length times the width, which is 4, and this gives 80 meter squared. Okay, now we need to look at the triangle parts. If you look at this triangle, we have something like this. Okay, and we have this part. Okay, now you have to be very careful. First, we need to find what is the length of from here to here. As a quick one, the whole of this length from this point to this point is 20. That is, from this point to this point is 20. Now, if from here to here is assumed to be 2 as given, and from this point to this point is also 2 as given, then we need to know this part. So this part, which is here, is going to be the 20 that we know for the total length minus this 2 and this 2. 2 plus 2, that's 4, so we have minus 4. So that means this is 16. Okay? And if this length is 16, look at this blue dotted line, splitting the line into two parts. So into two parts, so half of 16, that means this is 8 and this is 8. Okay, and finally what we also need to know, the dotted line, which is this, is given as 12 meter. Okay, and in the rectangular part we know this part from here to here as 4 meter. So if I know from here to here as 4 meter, for me to get the remaining part of the triangle is going to be the 12, which is the total from this point to this point, minus from this point to this point that I know as 4. So the height of the triangle is 8 meter. So I have the height of the triangle as 8. Okay? Now, for this triangle, it is in two form. We have this part, something like this, and also we can see something like this joined together to give us what we are seeing above. Okay, we've known that the height is 8, and from this point to this point is also 8. The same thing applies to the second part, 8, and this is also 8. So if we find the area of one of these, it's going to be the same thing as the second one. Okay, so the area of one part, let's say A, and this is B. The area of A is equals to the formula for finding triangle, 1 over 2, that is half times base. The base here is 8 times the height of the triangle, which is also 8. And this finally gives 2 can divide this 8 to give us 4. Then we are left with 4 times 8, that is 32. Okay, so it means that the A part area is 32 and the B part area is also 32. So the final area of figure 1, the entire figure 1, okay, is now that of this A plus that of B. So that is 32 plus 32, or 32 times 2, okay, plus 32. And that finally gives us 64. Good. So therefore, the area of the entire figure is now the area of part 1, as it's seen here, plus the area of part 2. And that gives, area of part 1 is now 64, plus the area of part 2, which we got as 80. And so finally, this gives us 144. 144 meters squared. And that is it. Please take notes. To find the area of composite figures, you have to observe clearly to split the composed figure into several parts, then apply your formula. And that is going to be the end of today's tutorial. Please remember, kindly subscribe to our channels on YouTube, Prof. Dan Tutorials, and always get our updates. Thank you very much. Don't forget, solve more examples. That is how you can make yourself a mathematics giant. Bye bye.